The other thing, oh, the lockdown browser. Again, this is online class, so I give you a specific time to take the test. We are using the lockdown browser. So try at least once to take the quiz using the lockdown browser, download it and take it to be able to take the actual test. If you don't do that during the test, you will have problems. So make sure you download this lockdown browser. Okay, download here on your laptop or computer, so you will not have problems during the actual test or quiz. I use the lockdown browser for all the quizzes and tests. Okay, so make sure you download it before. That's why I put the link and I'm recording that. I am sure I will have students after the test. They will tell me, oh, I couldn't take the test because I have problems with the lockdown browser. So I will post this recording and I will remind you to tell you if you have problems with the lockdown browser, solve the problem before the test. We have 2 weeks until the test, okay? At least 2 weeks. So again, make sure that you download this on your computer or laptop before the test. Okay, that's very important. You know, I know this happened to students on the fine. I cannot do nothing, you know, if you do not like follow the instructions and you come tell me, oh, I couldn't take the test because of the lockdown browser, because you supposed to do that 2 weeks or 3 weeks ago. You don't have to wait until the actual test because you didn't take the practice exam, you know, that means you don't care about your grade. Okay. Anyway, so let's move to chapter 6, part 2. We talked about the control charts and we said we are covering control charts for X bar and R. And we said we are using the following equations. So to calculate the upper control limit X bar, this equation, the lower control limit is this equation. First, we start by finding the X double bar and then find the A2 from the table. And I showed you the table, and then find R bar from the data we are given, and then plug in the information here and here. And for the R chart, we have upper control limit R is equal to D4 R bar. Lower control limit R is equal to D3 R bar. Okay, that's what we usually do. And we had oh, this is the equation for the upper control limit. This is for the lower. Of course, the D3. And if you have a question, you can stop me and ask a question. This is very important. This is very important thing. You know, it's very important tool. We use it in Six Sigma projects. Okay. So we said for this example, here for this example, we have x1, x2, x3, x4. We have 20 samples, size 4. So the sample size is 4 because what happened here? The sample size is 4 because we have x1, x2, x3, x4. We have 4 data points for each sample. This is sample 1. So to find X bar, I need X double bar. I need to find X bar here for each one. Add them up, divide by how many, and then you will get X bars, and then you will have a total here divided by, I think we did that. Let me check the Excel sheet. I will do it quickly. Um, where is this? It should be here. Okay, that's what we did. Usually I do it in Excel because it's faster. So I found the average for each. So this is the average for this row. I find the average for each row. I use Excel and then at the end, the total is 206. So since the total is 206.5 divided by 20, this will give me how much? 10.325. This is the X double bar. Okay, the grand average, the average of averages. Okay, and the same thing for the range. The range is the maximum minus the minimum. For example, for sample 6, we have 12, 11, 10, 10. So the range is the maximum 12 minus 10 is 2. I do the same thing, and then this is the total. So R bar is equal to 125 divided by 20, which is 6.25. So now I have X double bar and I have R bar. What I need to do, I need to take these numbers, plug them in the equation. So the upper control limit X bar is equal to X double bar plus A2 R bar. So X double bar, we said it is equal to 10,325 plus A2. Where do I get A2? We said A2, we get it from the factors table. It is based on the sample size. Our sample size here is 4. So I go to the factors table. It should be here. I open it. This is the factors table. And then I look for sample size 4. So this is sample size 4. You see, sample size 4.729. This is the A2. And I need also D3 for the R chart, which is 0. And D4 is 2.282. Again, sample soil size 4.729. I go back here and plug in 0.729 times 6.25, and then I find the upper control limit. You should find the final answer. The lower control limit for X bar is similar, 10.325 minus this value, minus 0.729 times 6.25, okay? And then what we did the upper control limit R is equal to D4 times R bar. D4 we said it is 2.82 times R bar 6.25, and I find the answer. The lower control limit R is equal to D3 times R bar. 0 times R bar is 0. Okay, now I calculated all the control limits. The calculations are here. The steps, how to use the table. See, I put here. Don't use this. You can use it if your sample size here is like appear here, but use the main one. Some students ask me, oh, where is sample size 6? So you're supposed to use this. This is a sample. I just here put this slide for you to show you how to use. And then we build the charts. We already did. That's what we did last time. And there is one more thing in the next example. This is a similar example. where you need to read the question. So a hard break process is used with some technology. We wish to establish statistical process control for flow width of resistant process using X bar and R chart. As we said, we only using X bar and R chart. You know, we are just covering X bar and R chart. In the book, they have like several charts. Just study the X bar and R chart and use these equations. Don't use the equations from the book. These are easier. The book is they use different like formulas. Just use these formulas, okay, which I'm giving you. So 25 samples, each of size 5. Each of size 5. So the sample size is 5. The specification limits, the specification limits are what? 1.5 plus minus 5. So when you have specification limits, you break it down to upper specification limit. You just add the tolerance, this tolerance, the lower specification limit. You subtract the tolerance. So these are the specification limits. Later, we will be using them. We do the same thing. This is our data. If you are given the total, so I don't give the X bar here. If I give you a question on the test or the quiz, I don't give you this. I will ask you to calculate X double bar is equal to what? The total here, I give you the total because you need time to find the total. Divide by 25. This is X double bar. R bar is equal to this total, 8.132 divided by 25. So now I have the X double bar and R bar. You see, 8.1 divided by 25. 37 divided by 25. So this is my X double bar. This is my R bar. So based on the equations for the X, the upper control limit X bar, I need X double bar. I already got it. 1.5. I need A2. A2 based on the sample size. We said for this example, the sample size, how much? I go back. The sample size 1, 2, 3, 4, 5. So I go back to the table and find the A2 value related to this is 0.577. I need D3, which is 0, and the D4, 2.114. So now I can do all the calculations, plug in everything. You see, I plugged in the 0.577 times R bar. I got the upper and the lower control limit. And for R chart, the D3 is 0, so the lower control limit is 0, and the upper control limit, I have the D4 value. Then I plug in everything in Excel and create the charts which I want. So the other thing which we are going to learn, I think we stopped here last time, but that's fine. So the X bar and R chart provide information about the performance. So we can, so now when we look at this chart, we say, oh, okay, the process is in control. What is in control means? In control means that all my data points are within the limits. This is the upper control limit. This is the lower control limit. So everything is in the limit, okay? So that means it is in control. But the question, does this meet the original specification or no? We don't know because that's based on what we actually have. We need to compare it with the original specification, the original design, the blueprint. That's what we need to do. How we do that? By calculating what we call the capability index. To calculate the capability index, there are like several capability indices. One of them is CP, is upper specification limit minus lower specification limit divided by number 6. This is number 6 times sigma hat. Okay, so sigma hat is the estimated standard deviation So I know this. You remember in the first slide, I said I calculate the upper specification by adding the 0.5 and the lower by subtracting 0.5 from the specification. So I need, this is number 6, and I need this. How to calculate the estimated standard deviation? It is equal to R bar, which I already have, divided by D2. D2 is based on the sample size. The sample size here is 5. So I go back to the same chart. That's important. You have this chart printed and put it in front of you so you can use it anytime. This is my D2, you see? I use this to calculate the standard deviation, 2.326. So I would say 0.325 divided by 2.326. This will give me the standard deviation which I am looking for, which is 0.1398. This is the standard deviation I'm looking for. Then I plug in the numbers, upper specification limit minus lower specification limit divided by 6 times the standard deviation. This will give me 1.192. 1.192. This is the CP. Okay, what does this mean? This means that the spread of my process, let's say this is the upper specification limit, the lower specification limit, and this is the 6 sigma, which is this. Oh, my process, it's good, but if you have been asked, is this process is capable, you say no. Why it's no? Because we are using 1.33 for capability. If the CP is below 1.33, so we say the process is not capable. But if it is above, the process is capable. So we say here 1.192 is less than 1.33. So the process is not capable. Okay, it's not. Some it depends on the industry. Some they use 1.25, some they use 1.33. So we'll use 1.33. Actually, if these two values are equal, there is a chance that all the products are within the specifications. But they added here 0.25 and some they added 0.33 to like have more room. If the process shifted, it could be here. Okay, so they have more room for variability. Okay, and then they said, oh, this index does not involve the average of the process. So it could be 1 or 1.5, but if the process shifted here, it doesn't tell you if the process is centered. Centered means both of these are at the same center here. This is mu or x double bar for the process, which is the middle. This is the 6 sigma. If it is not centered, that means the process is not good. So now they came up with another one. They said, oh, let's use CPK. CPK involves the mu. When you see mu, for us, mu actually in statistics is the population average. We use X double bar, which is our average of averages, as average. So this represents, or it's an estimate for mu. So we find here the upper, the CPK upper and CPK lower. So the CPK upper is upper specification limit, the same specification limit we calculated, which is equal to 2 minus X double bar here. Mu is equal to X double bar in our case, divided by 3 sigma hat. 3 number 3 times sigma hat, which we already calculated. We will get 1.17. We do the same thing. We get the lower CP lower is equal to X double bar or mu minus lower specification limit, which is 1 in our case, divided by 3 times 0.1398, and we get the lower CPK lower. And what do we select? We select the smaller one. So we select this. So because CPK is the minimum of the upper and the lower, so our case, we select this. Okay, that's, oh, this is the table. I put the table here on a specific slide in the last slide. Okay, you see this slide, right? Everybody? Hello?
Yes, we see it.
Yes, see it.
Okay. I want you to calculate X double bar. Now, what's X double bar? Based on this information, what's X double bar? Any answers? Where did it go? Here. X double bar is equal to 1590.6 divided by 20. How much the answer? How much the answer for X double bar? Hello? Any of you have a calculator?
Yes, sir.
Yeah. Find the answer,
Okay.
please. Find the answer. And after you find the answer, you see my screen?
Yes.
Yes.
Okay, since you see the screen, so I'll give you like 2 minutes to submit the answer for X double bar here, okay?
Okay. And can you go back? Can you go back to the screen you just on?
Yeah, I will go back. I need to create this first.
Okay. Thank you.
Okay. Okay, go ahead and find, just type the answer for this, okay? $1590.6 divided by 20. Just type it on the quiz there.
You want us to like round our answer to the nearest 10?
Yeah, just write the answer. Just type the answer and that's it. What's the answer? Just type the number.
Sir, I think he's asking if you want us to round the answer or keep it the same.
Keep it the same. Okay, now we are done. So if you have any questions, feel free to contact me. Everything, I will post this recording tonight or tomorrow. So make sure you study the material and get ready for the test. Okay. Any questions? Hello? Questions?
I sent you an email, sir.
Okay.
No, sir. I don't have any questions.
Okay.
No questions.
Okay, thank you.
No question.
Thank you. Bye. Have a good day.
You as well.
Thank
Thank
you.
you.
You too. Have a
Thank
good
Thank
day.
you, too.
And then tomorrow at 12:10, right?
Yeah, it's 12:10 in my office. Yeah.
Okay, I'll be there.
Sir, did you get my email
Email, let me see. Regarding what?
regarding the textbook and the homework?
You missed the homework?
Yes, I was one of the students that couldn't access the
So
textbook.
which assignments? You know, I extended the 2 assignments which are due today. You just need the first 2 assignments, right? Yeah, specify which assignments, okay?
Okay, yeah, I emailed all the assignments that
Okay. I
it's
will.
Nina.Hervey, you missed it. Yeah, right there.
Okay. I will take care of that. Okay.
Okay, much appreciated. Thank you.
Thank you.